Hi, this is Tracy Walker. I am a senior security engineer with SUSE. I am a specialist with NeuVector, and today I'm going to be presenting a talk I gave at the RSA conference recently in April. This talk was selected as Zero Effort, Zero Trust for blocking zero-day attacks in Kubernetes. What will we learn with this talk today? Well, we are going to learn a little bit about zero trust. This is more of a pragmatic, kind of an easy way of learning what zero trust actually is. We'll talk about some misconceptions. I'll give a real world example, kind of the differences in value of why we want to use zero trust for security. We'll talk a little bit about creating zero trust in Kubernetes, but then we're really going to, kind of focus on how NeuVector can make zero trust very easy, and even in a like kind of a security event, rapid response kind of deployment, how you can use NeuVector to even stop an attack that is in progress. So lots of cool stuff. So let's get started with what is zero trust security. Well, first thing to understand is this is a concept. This is not a product. This is not something you can buy. This is really kind of a way of defining a perimeter and then securing that perimeter. In fact, one of the main things that we talk about with zero trust is deny by default. So that means everything is denied. You are going to specifically allow things to come into the environment. And we can apply that to users. We can apply that to network connections. There's all sorts of ways you can kind of apply zero trust. But obviously, first thing we always start with is it's got to be denied by default. So we're going to deny everything that we're going to let into this perimeter. And that can be applied to, again, devices, network, physical locations. The four characteristics that we want to look for when we're talking about zero trust are, well, like I said, deny by default, an enforceable perimeter, really kind of a defined perimeter, like we know what gets in or out of this perimeter. You can even call it as like a gateway, like a firewall. If we deny all by default in a firewall, that means all the ports are going to be deny, and we have to specifically open ports to allow traffic to flow through that firewall. That would be a kind of an easy deny all by default, kind of a zero trust example. The controlled elements are authenticated and authorized. We're used to seeing this with like role-based access control, right? When you log into a website with your user ID and password, that's essentially zero trust because it is deny all by default. If you don't have a user ID, you can't log in. So you're authenticated as to, yes, we know who you are, and then you probably have permissions once you're in the website as to what you can see and do, right? So that's, again, another example of zero trust. Continuous monitoring means that we're always watching that. So in our example in a moment, we'll talk a little bit about what that continuous monitoring kind of looks like. So misconceptions about zero trust, there are many. One, that it's a product of technology. It's not. It's a concept. It's a way of applying or defining some security layer. It's all about authentication. Authentication is part of it, but it's comprised of different things, like we were just talking about the characteristics we were talking about before. Some people will argue, well, zero trust means you have to authenticate and authorize for every single activity. Not necessarily the truth. You're defining a perimeter, and the gateway into that perimeter means you get authenticated and authorized to go into that perimeter and do certain things. But we're usually not rechecking every single time you're in the environment. For example, we'll use an example of airport. When you go through security, you don't get checked at every store every time you go to a restaurant to see, oh, well, do you have your ID and your plane ticket before I serve you this hamburger? No, they don't authorize everything that happens once you're inside that perimeter, right? Zero trust is expensive and complex. Well, we're about to prove that it is neither of these, because if you do it with NeuVector, it is neither expensive nor complex. Eliminates the need for other security? No security layer eliminates the need for other security layers. What we're talking about is security in depth, multiple security layers. Zero trust can give you certain security layers, usually around a perimeter, to an environment or into a workload or whatever the case may be. Zero trust is only needed for high security environments. Again, no, good security layers can be applied in any environment. Sometimes we'll talk with people who say, well, we're not ready for this zero trust. That's like for really serious security. If you're doing security, this is an easy way to do security and kind of define it and be able to create these gateways or checkpoints where you're authenticating, authorizing, and all of these things. So it's a handy tool to have in any environment where you're trying to apply security. Does not mix with other security layers. No, zero trust works with other security layers. You want multiple security layers. No security layer is perfect. Every security layer can be exploited. That's why we do security in depth. We create multiple layers so that if one layer gets breached, another layer catches what got breached, and so on and so forth. So I mentioned good security, and it's important to kind of talk in security teams as to terms as to what is good security. Good security is one, it's the ability to control an environment while minimally affecting its function, right? We want to control an environment, control a perimeter, but we don't want to cause that environment to slow down. We don't want to impact productivity, or in software development terms, velocity. We don't want to slow down software development. We want to keep that software flowing, making changes, updates, etc. But we want to make sure that security is part of that. As I mentioned, defense in depth, we want multiple security layers. So the more layers I can create, the better. But if I'm adding security layers that create a lot of management overhead or start to restrict my business or the function that we're serving, maybe those security layers are not exactly what we want. So usually every environment is a bit unique. And so every environment can have certain security layers that are contributing to the goal of security without impacting the business. As I mentioned, no security layer is perfect. And this is one that sometimes we have to remind ourselves that, sometimes we'll say, well, if I was able to run this command in this one place, I gotcha. Yeah, but you kind of started in the middle. You skipped all these other security layers to, find a way to gotcha with one security layer. And it's like, aha, you guys are not secure. No, you wouldn't have even got there, right? There's lots of security layers before and after usually one security layer. So no security layer is perfect. And we always assume that we are compromised. We always assume that something can get through this one, and then maybe we catch it here. And then if it gets through that one, we catch it here, right? That's kind of the way security is made to work. Security layers work best when minimizing the weaknesses of other layers. So again, think of it as nets. Every net has holes, right? So you want to have nets kind of stacked together so that the hole of one net is in the netting of another, and then the hole in that net is in the netting of another. And eventually we catch or stop what we want to control within that environment. Is it possible to have too many layers? Of course. If those layers are impacting you negatively, that might be too many layers. So it's not so much a matter of how many layers, it's are they effective? Are we controlling the environment? Are we able to prove that we are not compromised in that environment? So that's another way also of knowing how many, if you've got the right number of layers, can you always prove that there is absolutely no way you are compromised in any environment? And you can prove that because of these security layers that we are monitoring or that would notify you of that. Another key for good security is understanding your sources of truth. Where are we getting data? Are we getting it from one place? And where is that place getting that data? Is it being created there and then shipped somewhere else, or is it being received? Are there other sources of data that can verify that source of data that are independent, right? So if I have two independent sources of data, all both verifying the same thing, I have greater trust that I may be getting the entire picture there. So with that, let's talk a little bit about real world zero trust. And this is not an analogy. When I gave this talk in San Francisco in April, I had some folks come up afterward and say, oh, that was a great analogy that you used with the airport thing. This is not an analogy. This is zero trust. If anybody has flown through an airport and you have gone through security, you have gone through zero trust. You have experienced it firsthand. What's our perimeter? Well, it's the airline terminals, right? You're seeing a picture here of Denver International Airport, and you can see right there all the security folks in blue and the line of x-ray machines. That is literally the perimeter for getting into the terminals, right? So as we go through these things, what's the first important thing we know about zero trust? Deny all by default, right? So everybody is being denied until they go through security. How are they doing that? Well, we're controlling people, right? That's the thing that we're controlling going through here. And really, we're controlling people and weapons because you're going to get x-rayed as well. We want your ID, we want a boarding pass, so that's your authentication and your authorization. You have authenticated ID, you've been authorized to fly on an airplane, and now we're going to scan you. We're going to x-ray your bags and your person to make sure you're not carrying anything that we want to prevent from getting into this zone, this perimeter that we have. Once you get into that zone, there is continuous enforcement. For example, there's lots of exits that say, if you go through this door, an alarm will sound and you'll be out on the tarmac. Well, if you go through that door, you will get to experience firsthand continuous enforcement. You'll probably be taken into custody and questioned. Why did you break security? Why did you, create a hole in our secure perimeter, right? We have a sanitized environment where we know no one person is in there with it is not authenticated, authorized, and doesn't have a weapon. So if you go to break that security barrier, they're going to want to talk to you. And that's kind of what zero trust is. If you break that perimeter for any reason, we want to know about it. We want to be able to stop it. Now, if you're aware, there's also this thing called a no-fly list. A no-fly list is an example of threat matching, but not zero trust. Now, why is this? Well, think of a no-fly list. It's going to have names of people that are not supposed to get on an airplane for some reason, right? Is that list deny all by default? No, it is not. Deny all by default is everyone who has to go through this, x-ray machine and all this kind of stuff, right? So once you're authenticated and authorized, then they check your name against this no-fly list. And if your name appears there, you won't get to fly. So that's another layer of security, yes, but it's threat detection. Why? Because the names on that list are what we're matching against. This is not deny all by default. Basically, it's allow everyone by default who has passed these other layers, except for these people, right? Or these threats, right? So this is more like threat recognition, like threat signatures. You can match a threat and say, ooh, that looks like a threat. But if you don't know what that threat looks like, you have to fall back on your zero trust to say, the zero trust is not allowing this. Speaking of zero trust versus threat signature matching, let's talk a little bit about threat signature matching. So on the left here, we see some threat signatures like CVEs, data loss prevention, where we're looking at network traffic to find credit card numbers and things like that that are egressing your environment, or network attack detection, where we're matching a signature on a threat that's coming in through the network. Another example of that is OWASP top 10 there. Emission control is also kind of a threat signature, not so much a threat signature as much as it is checking certain values, checking for certain settings that you want to allow or disallow with images that come into a cluster. The zero trust controls, we can do network policies, we can do container processes, even registry origin, like we can zero trust using for admission control. One zero trust control you can actually do with NeuVector is only allow images to come from specific registries, right? So that's kind of a deny all registries by default, only allow these registries to, allow us to pull images from those registries only. And of course, I mentioned before, role-based access control. Whenever you log into an environment, the permissions that you have, that's zero trust, right? It's deny all by default. We know what the perimeter is, authenticated, authorized, et cetera, et cetera. So zero trust in Kubernetes. What are some examples? So that we've talked about the role-based access control. Node and container processes would be something that we might want to zero trust. Deny all processes except for the processes that we want to specifically allow, that allows our workloads or applications to operate. East-west network traffic. So inside of a cluster, we have this east-west traffic and then north-south. So north-south is usually the egress and ingress of network traffic into a cluster. And then the traffic that's flowing within the cluster is considered east-west. Well, this is another thing we could say, deny all that traffic, allow specific traffic that we permit through network policies, and constantly monitor and things like that. So we've explained the north-south. So this also may be another way of doing zero trust, kind of like the firewall example that I was talking about before. So in NeuVector, let's show some examples of some network policies. So The first thing you'll notice about these network policies, this is a screenshot from NeuVector, is these are all allow rules. So that is your first clue that this is a deny by default environment, right? Because we don't have to have deny rules, because you can see down here at the very bottom, deny all connections that don't match any of the above rules. So that's deny all by default, except for these things. Now we do also, in NeuVector, we do support deny rules. Now why would we want to have a deny rule if we're denying all by default? Well, you may have a broader allow rule, but within that allow rule, you may want to have very specific things that you will deny. So you might, this is an ordered list. You can see here, add to the top. So you may add a deny rule that says, well, for this very specific address, I want to block that. But for the more general DNS address, for the .com or whatever, we'll allow that traffic, right? So this gives you a way to do denies within the allows, which is in a greater deny, if that makes sense. Another example of some zero trust policies, here's some process profile rules. Again, notice the allow rules that we have here. So this is going to take us to kind of the point of this whole program, is a demo of zero effort, zero trust to block a 0 day. So to do this little demo, what we're going to do is in the NeuVector application. So again, NeuVector you can deploy into a cluster via Helm. It's automated, and the configuration, there's a kind of a broader enterprise integration where you can plug it into your existing scene tools and things like that, or kind of a rapid response where you don't integrate with anything, but you deploy it into a cluster, quickly gain control of processes that are happening and be able to turn things off if you're like experiencing an attack like we're about to show you here. So the way NeuVector works is we have what's called a discover mode. So the discover mode is going to learn all of the network connections and processes that are going to run inside of the cluster. So it's going to learn and create policies, those allow rules, based on what it sees. Doesn't mean that it sees good or bad. It just sees what it sees, and it creates rules for those, right? So we can look at those rules. We can say, yeah, that all looks right. That's what the application does. And that becomes our baseline for our zero trust. So in the monitor mode, we no longer learn any policies. We don't learn any new activities. We basically alert to anything that we haven't learned before. The protect mode, which we will use when we're going to learn, we're going to move it to a protect mode. I'll explain the steps here, but just know that the protect mode means we're going to block. We're not going to allow anything that we haven't seen before, right? So I'll kind of demonstrate this with NeuVector. And the steps that we will take here is what we're going to do is we're going to look at some security policies. So here in our environment, let's take a quick look at these policies. So I'm going to use this container right here, and you can see we've got a couple of processes here that we see. So this is this container is running this Java that you see right here, and pause, and we also have some network rules. So you'll notice also that this is in a monitor mode. So what we're going to do is we're going to delete those policies. We're going to move to our discover mode. You're going to see the application that we're talking about. We're going to relearn the network and process behavior. This is all automated, so you're going to just see it kind of happening, but it's going to be very, very fast. Then we're going to move to that protect mode, and in that you're going to see the zero trust enforcement. Then we're going to even do an attack, so you can see how we can detect a threat detection, which is not the zero trust, but we can then, by moving to monitor mode, we can actually simulate what a 0 day would look like. And then you'll be able to understand why the zero trust is so effective, because zero trust means that I don't need a signature. I don't need to understand what the threat looks like or what the threat does. All I know is it is not my application's behavior. So anything that's not my application behavior becomes suspect. That's why zero trust is so effective, because I don't need a list of names to be able to say, you're not authorized to do this. I know who is, and I know what they're authorized to do. So zero trust gives you a way to block anything that is not known. That's why it is so effective. So yes, the final thing we'll do is we'll do this attack for this remote code execution, and we'll show kind of what that 0 day looks like. So again, we're going to do this quick demo. Again, all of this is 100% automatable. These are behavior-based security policies. So the behavior that we're seeing is going to be unique to the application. No two applications are really alike. They're going to have unique behaviors. The network identification we're doing is going to be at layer 7. So there's a lot of products that will do layer 3, layer 4 network rules. That's like kind of having a map of where things are supposed to go as far as network traffic. Doesn't really show you what's on the map. Like if you got a map, doesn't show you the cars that are on the map. Google Maps does a little bit, right? But yeah, it's layer 3, layer 4 is going to be like the routes. You don't see the cars that are on the route. You don't see who's driving the car. You don't know what kind of payload the network traffic is going to have. What's the car have in the trunk, and you don't know if that network traffic has reached its destination. Right? Did the car get there? So that you're missing if you're not doing like the layer 7 deep packet inspection that NeuVector is doing, and that gives us a lot of information because now we can validate that layer 7 traffic. So we can identify what kind of traffic it is, and we make sure that it's properly formed traffic so that it's not containing some threats. There's not a body in the trunk, right? The network threat detection is part of that. So we do have signatures that we can detect these threats. You'll see that in the demo. And again, these are behavior-based network policies, just like the behavior-based process policies. But these are different layers of security, right? Process layers versus network layers. So we're adding lots of layers here for individual processes, which means we have multiple layers there, as well as the multiple network connections that we're going to allow or disallow. So let's go to the demo. So this container, and I may have to bring my browser down. So this container that's running right here is running this little website right here. And I do this demo a lot, but it's just very effective at showing us how NeuVector works and how zero trust works. So as I said, we're going to take these processes, these process rules that allow the Java process that runs this website. That's the Java process right there. We're going to delete these. So we're going to delete those rules. Now there's no process. So now because we're in a monitor mode, we don't block anything in monitor mode. We only alert. So yes, this will cause some alerts like, well, there's Java running. You didn't allow Java. Yes, that's okay, but we're not blocking anything. So it's safe, right? This is perfectly safe. No performance impacts because this is all passive. The network rules, we manage those in the network rules section. So we'll just select these two. We'll remove those. We'll save this policy. And then this policy will get synchronized among all the enforcers that are running on the nodes. So now returning back to our group, you can see there are no network rules and there are no process rules. There are also file access rules that we're not going to get into today. We're just going to focus on the process and network rules and the zero trust with those. So as I mentioned, we're going to move this to our discover mode. Discover means we will create security policies for processes that we see. So we'll go to the website, and how do we get processes to run? Well, let's create a new order. So let's make this order for, well, I'll just give myself an order. So we'll give it to Tracy. Try to find the right keys. There's an amount. We submit that. We might edit colon. Now just go back. I'm just generating some HTTP traffic, right? If I come back to NeuVector and hit refresh, well, you see there's the Java and the POS. So POS is a Kubernetes process. So we see the processes running. That's what we were showing before, right? And yes, I'm starting to see some HTTP traffic. So we're building these rules real time. Let's add a few things here just to keep it really interesting. So if I can go to the correct screen, here we go. I'm going to bash into this container. Yeah, the very one that's running that website. And as I'm in that container, I can run some commands like, who am I? I am root. So this is privilege escalation. You don't want anyone with root privileges in the container. Root's very handy to have, just not in the wrong hands, right? With root, I can run all these commands, right? Let's do a wget to google.com. So we established a new network connection, right? I'm doing all these things in that container while we're in the discover mode. Did NeuVector learn those things? Yes, it did. I bashed into it. I did a disk usage and ls. There's the wget and the whoami, right? We saw all of those commands. We also saw the network traffic. See, there's that DNS. When I did the google.com, that was using a domain name, so we saw some DNS traffic. So we are building rules for this as we go. Now we're ready to move to protect mode. We have established our rules, and anything that is not these rules, we're not going to allow. But before I continue, I'm going to delete everything except the Java and the pause, because that's what we were detecting earlier, right? That's my normal behavior. All this other stuff was just me messing around in this window here, right? So we're going to delete that. And this is why you can use NeuVector as a rapid response tool, because in the protect mode, this means we're not going to allow any processes. This is enforceable zero trust, right? You can do the monitor mode zero trust and just get an alert when something is going on. And we'll show you that in a second. But this is enforceable as well. We're going to block any process that happens or any network connection that we have not approved. So again, I'm in this container already as root, right? Let's do those commands again. Who am I? Not permitted, right? ls, du. I could do other commands, like how about remove, recursive force, all the files on the container? Not permitted, right? This is why it's a rapid response tool. I was in the container in a live active shell with root. You could have deployed NeuVector, learned the behavior, put it in protect mode, delete the behavior you didn't like, and you can stop that attack just as it was happening. That's exactly how you can use that. In fact, notice I'm still in this container. If I exit the container and I rerun the same command to get back into that container, notice I can't get back in. I'm further blocked from doing that bash command. So if I go over here to my notification security events, NeuVector is detecting those events. You see all these deny rules or deny responses, the bash that I was just trying, right? If I wanted to allow the bash, maybe that should be part of my zero trust. I could review this rule, deploy it again right there. That was very fast. And now I can get back into it. But can I run other commands? No, because that is zero trust. We only allow the things that we allow. Let's do an attack. So I'm going to run, let's get the attack string here. So I'm going to run this attack. This is a real attack. This is a Apache remote code execution. And what it does is it's going to use the IP address of my website that we've been using. It's going to inject into it this netcat command right there. Get to the end of this. There we go. There's the netcat command on this IP address, which is the local IP address I have here on the 1337 port, and here's a shell. So basically what it's going to do is run netcat to create a shell, except that it's going to reverse shell. It's going to run it from the container and try to reverse it back to my home address. And to do that, I'm going to have a listener. So I'm using the same netcat command on the same port, 1337, except the -L means I'm going to listen. So we're now listening. I can queue up my command. So let's do the same thing. Who am I? I'll do an ls and a du, right? And those will kick off once that connection is made. So let's run the attack. Again, we're in protect mode. So when I hit return, I don't see anything happening here. Let's go back to our security events. We'll hit refresh with NeuVector. And you see up here at the top, Apache struts remote code execution, right? So we did this is threat detection, right? We detected the threat by matching a signature. This is not zero trust. So we blocked that. We saw the deny. We even did a packet capture. If I scroll down, you can see the attack right there. There's that netcat. There's my IP address on the 1337 port. This is actually unique to NeuVector, the ability to do a packet capture automatically when it detects a threat inside of a Kubernetes cluster. No one else can do that. Only SUSE NeuVector can do that. So we blocked it. Yay. What if this was a 0 day? What if we didn't have a threat to identify, right? So now we're going to go to our container. We're going to put this now in a monitor mode. Monitor mode again means we're not going to block this attack. We will alert on it. And you can see the bash, we added that a while ago. But these are the only policies, processes that we're supposed to allow. So we're going to attack it again in the monitor mode. And when we do this, you can see it timed out there. So clear my screen, queue up the command. Now remember, we have this window here, right? So this window is the listener. Now, if that connection gets made and the demo gods are good with me, we'll be able to show you what a real attack looks like. So I'll hit return here. You'll notice it responded right away. I got an HTTP 500 right there, which is telling me that I did hit that web server. And also notice over here, my listener, who am I? I'm root. That's a reverse shell. I am inside that container and I can run commands from that container. Notice that there's no prompt. That's because it's a reverse shell. I'm actually had the container call my IP address and make the connection from within. So that's the shell. What is NeuVector saying about all of that? Well, let's go to our notification security events. Now, the first thing I'll point you to, see all the alerts over here on the right-hand side, right? If I scroll down to the last deny, that is when we were in the protect mode, right? That protect mode was the deny. When we moved to monitor mode, we didn't block anything. So ignore the fact that we're even detecting this. Let's pretend that we missed it. Or maybe it's a 0 day, because that's what a 0 day would do. You wouldn't have the threat detection. That's why the zero trust is so important. Because see, there's the netcat, and there's the shell, and the who am I, and the DU. There's a network violation. There's my IP address right there. Every one of these is a layer of security because every one of these is a part of the net that could have caught the thing and stopped the thing from happening, right? Every one of these lines, we could have blocked the netcat, the shell, the who am I, the DU, the network violation. Again, we're going to ignore that. See the tunnel command by NC and the process profile. So we're seeing all of these violations. That is exactly what a 0 day is going to look like. It's going to look like somebody came in through a shell, through a tunnel, started running commands, trying to figure out what they can see, what files are there, can they download tools, can they get a rootkit, et cetera, right? This is the beginning of something you want to stop. And this is something you can stop with NeuVector. So that is how it is the zero effort. Well, like I said, the deployment of NeuVector via Helm, maybe 5 minutes. There might be some configuration changes you might have to make, but very, very fast. The configuration for NeuVector is a couple of buttons, literally turning on the scanning, changing the admin password. Everything when you install NeuVector is already in a discover mode, so it will begin learning immediately. And because of the enforcers and the architecture that we have, you can also change those operational modes, regain control of your Kubernetes environment in a real situation, and start to block these things. There's a lot of countermeasures that are kind of built into NeuVector that you can use, including quarantine, the protect mode. We have WAF and DLP, and so other things that we can use to secure the environment, and mission control rules, things like that. So with that, what have we learned? So, what can you go home and do right away? Well, we learned the 4 elements of zero trust. Remember, we got a perimeter. We are authenticating and authorizing. We are deny by default. That should have been number 1, right? Deny by default and continuous monitoring, right? So all 4 of those things really need to exist for zero trust. Enforcement doesn't necessarily have to be there. As long as you've established the perimeter and the way to detect authorization and authentication and monitoring it continuously, that's zero trust. The fact that you can't add the layer of, well, I want to enforce it, I want to block things, yes, you can add that, but it's not required to do zero trust. You can deploy NeuVector as a rapid response tool. I hope we've made that clear. Also works very, very nicely as an enterprise tool, which is traditionally how we see it being used. If you install NeuVector, you'll immediately be able to see security policies for all your network activity, for all the processes. This is also very handy for like troubleshooting or just for developers. We have had customers who install NeuVector for the first time in an environment and immediately detected network attacks, automated robotic SQL injection attacks, log4shell attacks. And you'll also get a report on all the vulnerabilities, security misconfigurations, things that NeuVector can do outside of the zero trust. Now, within minutes, you can secure an environment with NeuVector and the zero trust. You can use that protected mode as a countermeasure. And also, if there are CVEs that you can't patch, so if you know that you have exploits in an environment, but for one reason or another, maybe there's not a patch available, or by patching with a certain version, it's going to break other things in your workloads. You can use NeuVector to secure those environments and know that those exploits are not being taken advantage of, because again, the zero trust does not require us to identify what CVE is causing the thing to happen. We're going to stop everything from happening. And again, you can also use that live packet capture. So within minutes, NeuVector, remember, NeuVector by SUSE is 100% open source. This was formerly a licensed enterprise container security platform, and SUSE acquired it and made it open source so that everybody can take advantage of this really revolutionary technology. NeuVector has patents around the way we are able to tap that network traffic. That is unique to NeuVector. All the other container security products are either skins on top of existing Kubernetes security, or they're using things like syscall filtering, eBPF, things at the kernel level. NeuVector is network centric. We're tapping network traffic off of the VNIC, off of each worker node. So the layers that NeuVector is using are different than the competition. I never argue against any other products or other security layers, because again, we want good security. So if you can use NeuVector in combination with other security products, absolutely. Like for example, we're 100% compatible with Istio and Linkerd. So if you're using a service mesh, you can use NeuVector with those as well. All the images are free to pull. You can get all the code and your build tools. Documentation is available online. So everything that you want to use for security, you can download it today, install it into an environment very quickly and easily, and you can have zero trust with zero effort to block 0 days in Kubernetes. You don't get to ask questions in the video, but that's the end of our time together. I hope that you learned something and saw some value in what NeuVector can bring to containerized environments. Again, my name is Tracy Walker. I'm a senior security engineer with SUSE and NeuVector. Thank you for listening. Bye-bye.